I still think of USB power to my projects as being 5 volts. USB has come a long way and is able to provide other voltages, and with a more recent PD 3.1 standard is quite a flexible power source that can be controlled from an embedded device. Centylabs have produced some RP2040 boards that do exactly that. Let's take a look. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. Remember to subscribe and join the community. I tend to think of VBus on the Pico as being the USB VCC, and that being of course 5 volts. I limit myself to the 5 volts and 500 milliamps that is the base USB power spec. Though that might run a Pico 2 okay, it's going to struggle to run a Raspberry Pi, certainly not a laptop, yet my laptop has been powered over USB now for about 5 or 6 years. On the Raspberry Pi Pico, we don't get to negotiate the supply voltage, but the team at Centylabs have designed an alternative RP2040 board that can negotiate the power supply over USB-C. They were kind enough to give me a couple of demo units of this, the PicoPD Pro and the PicoPD products. These use diode incorporated RP33772 and the S version, along with some DC to DC converters on the board to do the power supply. If you like this video and it helps your learning or projects, why not drop me a cash tip using that super thanks button below the video or the payment link in the description. I'm saving these up to get myself to the open source conference in San Francisco, and I'd appreciate your help in getting me there, and I hope to see you there too. Please hit the like button on the video and subscribe for more.
This video is sponsored by WolfSSL. WolfSSL provides security libraries for embedded platforms like the RP2040 and the RP2350. In projects where I'm doing power control, I might want to use their libraries to authenticate the origin of commands to change the voltage, just to check I know it came from an authoritative source. Or I might use it to protect the firmware on the device through secure boot to prevent malicious firmware being loaded. WolfSSL libraries are available in both open source under GPL version 2 or commercial full support licenses. Go check out WolfSSL libraries today. USB-C power distribution is a complex area, and it's one that I'm not an ultimate expert in. But let's just take a little bit of a look at where the state of the art's up to. So USB-C PD 3.1 is the latest version of the standard, and that gives you up to 240 watts of power. So that's the sort of power we're actually getting into things like your laptop over USB-C, being able to charge and run your laptop off it. It also includes quite a lot of enhanced power management in that, in the way that we can actually ask for maximum currents, different voltages, and etc. It really is quite clever. But of course, to do that, it's actually using special cables and special power supplies. And I think it's become quite a complex area, because just working out what power supply and what cable we need to deliver what level of service, which all takes a little bit of work. On our client side for getting this power in, and with these two modules we've got from Centylabs, they use specialist chips to actually control that USB and communicate and negotiate what that power is going to be. And those are the RP33772S for the Pro and the non-S version for the PicoPD. Those are diodes incorporated chips, which actually do all of the communication and the clever bit. And then behind that, they've also got some power management on here to actually do DC to DC conversion to drop us down to the 5 volts and 3.3 volts that we're going to need for our environment. Now, the Pro version of this is the slightly cleverer version of the two boards. It can go up to 30 volts at 5 amps, which is quite a bit of power. And it can also take 3 different modes of USB-C power. So fixed PDO, which is a set of fixed profiles of voltages and currents that a power supply can provide. And most USB-C power supplies will be able to give a section of 5 volts, 9 volts, 15 volts, sometimes a bit beyond that. It also does PPD, which is more of a flexible power supply. So that will give us a voltage range and we can select a given voltage from in that range. And AVS is the latest version of that sort of capability within the 3.1 standard, and that also allowing you to actually specify what voltage and what current you'd like to get. The PicoPD is a little bit simpler version. It uses a lower version of the control chip and can only support 20 volts at 5 amps. It also can only support 2 of the USB-C power modes, so only fixed PDO and PPD. But that's actually, to be honest, quite enough for most of my projects. And the demo I'm going to give here is actually only using PPD and fixed PDO. I haven't got a power supply that would actually support AVS. So why would I do all this? Why would I use all that? Well, the nice thing about this is suddenly I can have a single power supply into my project, straight into my Pico board, which can provide enough power not only to run that board, but also to run things like motors and servos, and perhaps control things like my robot arm here, without me having to worry about having a secondary power supply. So all of the code for the demo I'm just about to show you, I've included on GitHub. So you can go and see the code there, and I'll show you the code in a second. But let's actually have a look at the demo. And what I'm basically going to do is go through the various fixed profiles that I've got on my power supply and step through them. And for each of them, I will get a different voltage. I'll be able to read what that voltage is via this board itself. And of course, I've got a multimeter here, which is also giving me information about the voltage. And I'm also going to go through and then step through the PPS voltages by actually selecting a voltage, and then I'm just going to up it by 0.2 volts each time and scan through. And again, I will be able to actually see not only the voltage I'm requesting, which I can see just there at the top of my screen, but also the voltage that I'm getting and reading on the board. And then we can see the voltage on the multimeter too. So this shows quite nicely that actually I'm in complete control of the power coming across that USB cable from my power supply. Now the library that Centylabs have provided for this is unfortunately Arduino, and I don't really do Arduino if I can possibly avoid it. So I've had to do a bit of a rough port of this over to the Pico SDK and then build on that. But that's been good because it's got me to actually look in a little bit more detail about what's in the library and what's possible with this board. So the example here is cycle. And let's have a look at the main code here. So really this is a fairly simple program. So all I'm doing is basically setting up the APC chip, which is on I2C0. So that's actually how the USB is controlled. It's actually using this chip on I2C0, and I've set that up. And I'm starting that off, and the first thing I'm going to do is display the profile. Now you didn't see in that demo because I wasn't actually showing you the standard out, but actually this will actually dump the entire profile of all of the capabilities of this power supply straight to standard I/O. Then I'm also going to set up my little OLED screen, which is what I'm going to showing you on that demo there. And then I'm going to interpret the capabilities of this power supply. So I'm going to work out actually how many PDO profiles the power supply has, whether it has PPS and whether it has AVS, and I will display a summary of that on the very top line of that display, which is sort of only in 8-bit font, so it was a little difficult to read, I must admit, even for me. And then the loop is basically going to go through and cycle through each of these fixed PDO profiles and actually select them and display them. So we can set each of the profiles and say I want that profile at 3000 milliamps, and we can then actually go and check what the I'll display which profile we're using, and I can get the voltage that I've actually received back and what the board is reporting, and I can display that voltage. And I'm going to do a similar thing for PPS, which is more of a dynamic voltage capability, so I can actually give it a true voltage in millivolts that I want it to give me, and a current. So I'm actually asking it here and telling it which profile we're using for PPS, what the voltage I want to get in millivolts is, between 3.6 and 20 volts, and I want that at basically 4 amps. And again, I'm going to read back what that voltage I've received is and display that on my OLED screen. And that's all the demo is doing. I have got little delays in here before I actually read back what the voltage is, because obviously it's trying to negotiate with the power supply and receive that voltage. That does take it a few milliseconds to sort out. So the library itself is basically a class-based library, and gives you a nice object which can do most of the stuff that you'd want to do. And this is the one that I've roughly ported. So capabilities here is about displaying the profile and setting the voltage in terms of fixed PDO, where you're going to a profile, or a voltage by using PPS or AVS. We can also read temperature, voltage and current, and there are some other more advanced functions around setting protection modes, etc. on this that are there and could be really quite nice and useful. This library's really got some really great base functionality, but it probably needs well, firstly, some more polished porting over to the Pico SDK, and I think it also needs rounding off a little bit in functionality. Things like you can't actually query the profiles very easily, so I can't actually see the PDO profiles. They're printed on the screen and the information's there, but there is no way for me to programmatically step through them and understand what they are so easily from within the code. So there are some enhancements I think that could be made to this library to make it more useful for applications. So what's my evaluation of the Centylabs boards? Well, from a hardware point of view, I think they're both actually great. When you review the specs and the designs, they look really good. They certainly seem to operate very well in reality, and yeah, I really quite like them. The demos are also clear that they've provided to show the functionality of these boards and actually how to control them and what they can do. And that's great because that gives you a real accelerator into really getting your project and understanding what to do. From a library point of view and languages, I guess there is a bit more to do. I think Arduino only is a little bit limited, really. I would like to see certainly Pico SDK supported. I'd also like to see something like MicroPython supported as well to make these more useful for the general community. And the library itself, I think the functionality in there needs to be a little bit wider and a little bit more thought through in exposing the capabilities of this platform. But generally, you know, I think these are really cool boards with some great potential, and I look forward to using them in some future projects.
So far, I've only played with the PicoPD Pro, but actually everything I've done, plus indeed every power supply I've connected this up to, would work with a slightly cheaper PicoPD. I think these boards have a lot of potential. For some of my robots, they could be used to power it rather than needing a second power supply, or perhaps build a bench power supply of my own. How would you use these boards? If you like this video and it helps your learning or projects, why not drop me a cash tip using that super thanks button below the video, or perhaps the payment link in the description. Remember, I'm saving these up to get myself to the open source conference in San Francisco, and I'd appreciate your help in getting me there, and of course I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please do hit that like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.